This is the homework solution for the MVP 1.4. Number 1, we start with the ready. Number 1, it gives us a function of n equals to 5 plus 8. There are going to be certain values that we are going to be plugging in. So for the first one, we are plugging 4. Okay, so here, it's what we're basically doing is we're going to plug in the value of 4 in for n. That is exactly what you're doing here. Once you do that, you can simplify. Okay, so we can say that, right, the function of 4, which is this part, okay, this part which is in bold is this part, we can say the function of 4 is equal to the value of 28. Okay, this is what this means. Okay, so if you plug in the value 4 in this function, you get an output of 28. What happens when we have the same function but we are plugging in -2 this time? Right, when you plug in -2, what does that do? It asks us to plug in the value of -2 in for n, and it gets us -2 is going to be equal to -2. Let's see if that is correct. 5 times, so 5 times -2 is -10. You're still going to plus the 8. So -10 plus 8, it should be -2. Correct. Right? Just double checking the work. So what that means is, okay, what that means is the function of -2 is equal to -2. So you're plugging in -2 here for n, you're going to get the output of -2. Alright, so that's what that means. So next problem, I'm just going to be giving you the answer. The explanation is right here. It's just going to change because the function is going to change and the value is going to change, okay? But the idea for the ready remains the same. You are given this function f of n is equal to -2n plus 1. You're going to plug in the value of 10. So here you read this. Function of 10 is equal to. Once you plug in the 10 for the n, you're going to see, you're going to simplify that. F of 10 is equal to -19. Right? Then you're going to plug in -1 here into the function for n. There you go. Reduce that. Function of -1 is going to be equal to 3. Next, 3. Function of n is equal to -6n minus 3. Plug in, substitute in 5. Okay, I substituted that in. Okay, -6 times -5 should be +30. Minus 3, which should be 27. So the function of -5 is equal to 27. Next, function of 0. If you plug in 0 here, -6 times 0 minus 3. Okay, so we could say that -6 times 0 is 0, minus 3, you get -3 on the right hand side. So we say the function of 0 is equal to -3. 4. F of n is equal to -n. You substitute 9 in for the function, so you plug in, you substitute in 9 there for n. So we say the function of 9 is equal to -9. Next, function of -11 plugged in there. Negative times a negative becomes a positive. So that's why you would say the function of -11 is going to be your value of 11. Good. Let's look at example 5. Function of n is equal to 5 to the power of n. You're substituting 2 here into the value of n. So function of 2 is equal to 25 because 5 squared becomes 25. 6. Function of 3, you're plugging in 3 in here for the exponent. That is what is occurring there. In that process of the function of 3, it equals to 125. 5 cubed. 5 times 5 is 25. Times 5 is 125. Okay? Is there only 5 problems? No, there should be a 6th problem. Good. All right, 6. We have function of 3n. Substitute 4 in here for the exponent. Okay, and 3 to the power of 4, that should be 81. So we say function of 4 is equal to 81. The next one, f of n is equal to 3 to the n power, right? But you substitute 1 in here for n. So f of n is just equal to 3, right? 3 to the power 1 is in of itself. 7. Function of n is equal to 10 to the power n. Substitute 6 in here. 10 to the power 6. There should be 6 zeros. 1, 2, 3, 4, 5, 6. So function of 6 is equal to 1 million. Let's look at function of 0. If we plug in 0 here to the exponent, what is 10 to the power 0? Function of 0 equals to 1 because anything to the power of 0 is equal to 1. Let's look at 9. Function of n is equal to 2n. You're plugging in 0 here for the exponent. Anything to the 0 power is just 1. So function of 0 is equal to 1. Next, function of 5 is equal to plugging in 5 here for the n value. So 2 to the 5th power. To the 5th power is 32. So we say the function of 5 is equal to 32. There you go. Alright, we're going to be looking at the set now. Okay. Alright, the set. Okay, let me delete that. Alright, so the set. We have number 9 here. Okay. You have the set. You start from the sequence. Okay, this is the sequence. 3, 8, 13, 18, 23. I've noticed right here, to find the common difference, all I did was I did 8 minus 3 is equal to 5. Let's do that again. So I found the third number minus by the second number, right? Because that's the next in the sequence. So 13 minus 8, that is also to 5. Whoop. That is also equal to 5. I can do 23 minus 18. That should be equal to 5. Do you see that? That is how I compute the common difference of 5. Okay? The recursive formula. So let me remind you what the recursive formula is. Right? The recursive formula for an Aromatic sequence. Okay? So let's just remind you. For an Aromatic sequence, we know that the recursive form is defined by this, right? We got this from our task earlier. The implicit form looks like this, okay? Or our beautiful y equals mx plus b. But for the sake of this, for the sake of the solution, I'm going to be showing it using this, okay? Then if you simplify it, you could get the y equals mx plus b form. Alright, so here we have the common difference of 5. The common difference is you're using that symbol d, okay? D equals to plus 5. The d stands for the common difference. Alright, so we're asking to find the recursive formula. So grab the recursive formula. Okay, I'm going to show how to get the solution here. So again, grab the recursive formula. Plug in d. D is the common difference, which is negative 2. Plug that in for d. Right? So plug that in, negative 2. That is how you get the solution of that. Okay? That's as simple as it gets. Next, the implicit form. Grab the formula. Okay? Right? Grab the formula. Right? Here you go. What is function of 1? Right? What is the first value? It looks like it is 11. So you're going to put in 11 here. Function of n minus 1. What is the common d, which is the common difference? I'm sorry, I'm doing this one. Sorry about that. The implicit form is this. Okay. 9, right. Okay. Function of 1. The first function of 1 is 3. Okay. This was the first value. let me make that red to make sure you see that. Okay. Red. Red. Okay. Because again, that is the first value. D stands for the common difference. I'm going to make that blue. That is blue here. Okay. I'm going to substitute that in. Okay. The first value is 3. The common difference here is going to be 5. Okay. Good. All right. How do I simplify that for the 5 and to get to this? Let me show you. Okay. Okay. I'm going to rewrite this so I can rewrite this in this format. Right. I'm just going to do some commutative property. I'm just going to write it like this: fn minus 1 5 plus 3. Okay. Right. So do you see how it's the n minus 1? So what I'm going to do is I'm going to go up 1. Okay. If I'm going to go up 1 here, so this becomes x. Okay. Or you can say that's 5x. This 3 here gets reduced by a value of 5, so it becomes negative 2. Oh, becomes negative 2. Do you see how it matches exactly with the y equals mx plus b format? Okay. That's if you want to do it like that. Alright. Okay. But there you go. Yeah, acceptable answers are you could have it in this format or you could have it in the y equals mx plus b. Either way works. Okay. Next, here's your common difference, negative 2. Let's see if that's correct. 9 subtract 11, that is equal to negative 2. 7 subtract 9, that is also equal to negative 2. Alright, just double checking, that is correct. Okay, so here's your recursive formula. F of n is equal to negative 2 plus function of n minus 1. Okay, remember, because this is the recursive equation for the Aromatic sequence. This is an Aromatic sequence because you have a common difference. Does that make sense? Okay. Next, we can do the implicit form. Okay. Remember, this was okay. This is the implicit form of the Aromatic sequence. Okay. Here you go. What is f of 1? F of 1 is your first term. So I'm going to make that red. Make this red. Alright. So here, subtracting 11. Your common difference here was negative 2. Good. Right. And I could show you how to get the y equals mx plus b. Check this out. I'm going to write it in. I'm going to write this like that. Do some commutative property. So there shouldn't be a negative 2 here. Yeah, there should be a negative 2 here. Right, hold on. Because the implicit is that. So that is the common difference. Alright, this here is the blue part. Forgot to note that. Okay, because that's the D here. So here, f of n is equal to, let's do some commutative property, n minus 1, right, negative 2 plus 11. Okay, good. Right, this is going to become x because it's gonna go down, right? It's gonna go up to the next term. This is gonna go to 13. The reason why is because the prior value here is 13. Okay, is the prior value, right? Which is the 0th term. Okay, that is how I got that. So do you see how it matches exactly with the linear equation of y equals mx plus b? Okay, that's just if you would like to see how it's basically the same answer. Okay, that was 10. 11. Again, the common difference here is negative 1.5. You're going to plug it into the recursive equation. This is the difference, which was d plus f of n minus 1. Next, the implicit form looks like that. That is y equals mx plus b. let me grab you the implicit equation for this one. Okay. Alright, so what is f of 1? F of 1 is the red part. It's going to be your first term, right? So that is the value of 3, right? Value of 3. And your common difference here is negative 1.5. So I could say negative 1.5. Okay, make this red a little bit. Make that blue. So you can see, make that blue. Because that is that substitution that is occurring here. Okay, color code so you can see the substitution. From here, what you do is if you want to find the y equals mx plus b again, right? Okay, rewrite it. So it's plus 3. Do some commutative property, right? So this has to go up. So this becomes x, right? So this also has to go to the next one, right? Which the common difference is 1.5, so it becomes 4.5 because the 0th term is 4.5. Do you see? There you go. Alright. Either form worked. You could have it this form or the y equals mx plus b form. Okay. Here you go. You have the go. So let me change this a little bit so you could see this. Alright. So they say what was Olaf's evaluation at noon? Okay. Let me grab paint for this image so we can do this in paint. Ooh, okay. Oh, that's not good. Hold on. Give me a second. The image was a little blurry. So I want to make sure that we got a good image to work with. Okay. All right. Okay, perfect. That looks like a good image. They say what was Olaf's evaluation at noon? So noon here is at 12 p.m. So I want to circle this as 12 p.m. to indicate to you we're looking for that. Look up at the straight line. Boom. That is roughly 10,000 feet. That's why I put 10,000 feet. Next, what is his elevation at 2 p.m.? Okay, I'm going to make that blue. Okay, and it says 2 p.m. correct? So blue, circle, 2 p.m. Okay, draw a line directly to it. Okay, over across. You sort of have to eyeball it. Okay, but understand that this is around the halfway point. So this one is roughly 7,500, right? So sure, that's why I guess this is roughly 6,000. That's why I guess this is basically 6,500. Okay, roughly in that ballpark. How much feet did Olaf descend from noon to 2 p.m.? So you're going to go from noon to 2 p.m. So you're going to go from noon. Okay. You're going to go from noon. You're going to go from noon, which is our red. Okay. To 6,500, which is our blue. That's why I showed the math here. 10,000 minus 6,500. 3 is a difference of 3,500. That represents that whole thing is represented by this. This decline from here to here. That is your 3,500 feet. Okay. Good. Next, Olaf reached the base camp at 4 p.m. What is the elevation at the base camp? So we're going to look at 4 p.m. Okay. Right. And we are looking for an elevator. So go up. That is that point. Go across. That is how you get 1,000 feet. So the question here is, during which hour was Olaf descending the mountain the fastest? Alright, so let's just grab a new of the image. Okay, just want to make sure that we are working with a clean image. Okay. All right, good. All right, so when we are looking here for the fastest descend the mountain the fastest, I would like everybody to understand that descend the mountain the fastest is referred to, you are looking for, question 16 is looking for the slope. Okay, this the steepest slope. So, right. So, okay, we have we have this. Okay, that's not bad. Okay, then we have from here to here. That's not bad. Let's go from here to here. Ooh, that's a little steeper. And let's go from here to here. Oh, let's make that green. Whoa. So, again, what does that represent? It means, whoop, solid line, good. So that should be the green. Green. Solid line from here to here. Why is it not going? Hold on. Purple. Oh, no. Okay, let me just grab this. The paint's not working. Give me a second. Alright, let's see if it's working now. So, red. Okay, goes from here to here. Oh, solid. Okay, I forgot to do the solid. Okay, so go from here to here. Good? Okay, next one, orange. From here to here. Then green, here to here. Blue, here to here. Alright, which of this is a steeper slope? Red? We're going to compare it. Okay. Okay. Looking at these three objects, 1, 2, 3, 4, which one do you see it being steeper? Okay. That's pretty shallow, that's pretty shallow, that's pretty shallow. This is really deep. That's why we say it's from 3 to 4, this blue slope. So we say from 3 to 4 is descending the fastest because the slope is the largest. The slope here is going down the largest, alright? There you go. That is your homework solution for August 27th, 2018.